Okay, here we have a farmer who's growing apples and bananas. The number of apples that he grows is represented by the random variable x, and the number of bananas that he grows is represented by the variable y. Notice that we have these. What are all these values? This is the expected value. This is the average number of apples and bananas that he grows. Because remember, apples and bananas are random variables, x and y. We don't know if this is going to be a lot this season or a little this season, but on average, it's 500. The variance represents the spread of those crop productions. The covariance is a variable or a value you probably haven't seen before. So covariance is relatively new. Covariance, all you really need to interpret from that is, if it's positive, it means that when the apple crop is high, the banana crop is high. Or when the apple crop is low, the banana crop is low. So they do the same thing. When apples go up, bananas go up. When apples go down, banana goes down. The opposite is true when this is a negative number. If the covariance between apples and bananas were negative, it would mean that when the apple crop is high, the banana crop is low, and vice versa. When the apple crop is low, the banana crop is high. All the same, we're going to take these values and try to generate the farmer's expected income by, first off, we have to create that income equation. The income, let's use a different color here. The income here, we're told that he gets $2 for every apple that he sells. But 400 of the apples that he makes go toward feeding his family. So he doesn't see the revenue from the first 400 apples that he makes. And in a similar fashion, he gets $3 per banana, but he doesn't see the revenue from the first 300 bananas. We're going to go ahead and distribute the 2 and the 3. We're going to call this 2x plus 3y minus 1700. So this is the income equation for the farmer. Now we need to figure out the expected value. Well, it's just as easy as taking the expected value of both sides. I'm going to say e of I equals e of 2x plus 3y minus 1700. And as you might already know with the expected value, and if you don't, this is a fun fact, you gotta learn this guy. We can split the expected value, or the expected value of the sum is the sum of the expected value. So we can say that expected value of 2x plus 3y minus 1700 is the expected value of 2x plus the expected value of 3y plus the expected value of negative 1700. So notice that every term inside this expected value got its own expected value. The next thing we're going to do a couple things. The 2 and the 3, the constants that are sitting inside the expected value as coefficients of x and y, can come out in front of the expected value. So I can say 2 times expected value of x plus 3 times expected value of y. And the expected value of a constant is just that constant. So the expected value of negative 1700 is negative 1700. Now we're almost done because we have expected value of x and expected value of y. They're up here. Expected value of x and expected value of y are there. We'll just take these numbers and plug them into the appropriate places. So 2 times 500, 3 times 700, minus 1700 gives me 1400, and that is the farmer's expected profit. Now we have to do a variance calculation. The variance is computed in similar fashion. We're going to have variance of I, taking the variance of both sides, we can split the variance up, but we have to throw in a covariance term. So this is where things get weird. So this is a really complicated expression. Variance is weird. We now can say variance of 2x plus variance of 3y, but now we have to say plus 2 times the covariance of 2x comma 3y. This is required for variance calculations, especially when you have 2 random variables. Notice that there's 2 random variables in this expression, so when I take the variance of this sum, I have to throw in this covariance term. The other thing I want to point out is that when you take the variance of a constant, or rather when there's a constant all by itself inside a variance, it goes away and becomes 0. So that's nice. We don't have to worry about the 1700 at all. I'm going to take this up to the next line and say, when we have a coefficient in front of our x and y inside a variance calculation, we have to pull those out in front, but we have to square them first. So 2, when pulled out, becomes 2 squared, and 3, when pulled out, will become 3 squared, which is 9. So we have 4 variance of x plus 9 variance of y plus covariance. Kind of the same thing happens. I pull the 2 out and I pull the 3 out, but I don't have to square them. So that 2 and that 3 will both come out. 2 times the 2 times the 3, when they all come out, gives me 12 covariance of xy. Now all these values are given. I think I should have variance of x, variance of y, and covariance of xy. So when I just take this guy, plug it in here, take this guy, plug it in here, and take this guy and plug it in here, I get 4 times 625 plus 9 times 2500 plus 12 times 475, and this all comes out to be 30,000 700. This is the variance. And that is the problem.